this next problem, let's take a look at some advanced distribution here, where we have a binomial multiplied by a trinomial, right? In each of these expressions, in each of these parentheses, right, we have, in the first one, 2 terms, and in the second one, we have 3. And the key with an expansion such as this is that we have to make sure that every single term, right, each of these 5, get multiplied with all the other ones that are present. That is to say, for example, this first term has to be multiplied by each of these 3. Same with the second term here, each of these 3, right? And we have to make sure we only do this once. So there's a lot of different ways that you can go about doing this. But in order to stay consistent, right, in order to not accidentally multiply 2 terms together twice, I like to follow a process that involves starting by selecting the first one of these in the equation and going through and multiplying that by every single term in the second one. Then repeating that process for the second term in the first, for every term in the second. So let's go ahead and do that, right? So for my first round, I'll go ahead and select my 2x, right, okay, by this little 1, and I'm just going to go through and multiply it by each and every one of these. And we can illustrate that by taking this little arrow. It kind of helps me visualize it because it's very easy to lose track of this. And I'll say, okay, what is 2x multiplied by 5x? Well, I know 2 times 5 is going to give me 10, and this is 1x, and here we have 2 x's, for a total of 3 x's multiplied together. So we get 10x cubed. Great. Where do I go? Well, I want to do the same thing now with the next term in the second equation. So I'll go ahead and draw my little marker here so I can keep track of what I've done, right? And I'll say, okay, here I have 2x, and over here I have a negative x. So I'll have 2x times a negative x, which will give me, right, we have a positive times a negative, so this will give me a negative. 2 is our coefficient out front, and we have 1x here, a second x, so we get 2x squared, right? And yet again, right, just to keep track first, I'll go ahead and multiply this by our third and final term in that second polynomial here, right? So that would be 2x times 2. And this time it's positive, right? So we have 2 positives, make a positive, and 2x times 2 gives us, and multiply our coefficients, 4x. Great. We have done our first segment of this, right? The first bit of this was taking care of this term right here. But now we have to address the 3. So go ahead and maybe use a different color for this, right? I'll say this is term 2. And we're just going to repeat that same exact process, right? I'll start with my lines. I'll draw it over here, and I'll say, okay, first I want a negative 3, right? We can't forget that this is a minus here. Our negative 3 times 5x squared. So this is a negative times a positive, meaning my result will be negative, right? And we'll have our coefficients first, right? 3 times 5 gives me a 15. Oh, that's hardly visible. Let me try, let's try neon green for this one. Oh, that's better. Negative 15 for our coefficients, right? And we'll go ahead and change the number up here, or the color up here, just to remain consistent, right? 2, we did this one. And there's no x here, so all we have is that x squared from that second term, right? Moving on, right? Same exact process. We're going to take this term and do the next one, right? And we don't have any coefficients here. We don't have any x's here. But what we do have is 2 negatives, right? A negative 3 times a negative x. And we remember, for multiplication, when you have the same sign, it flips. In the case of negatives, right? It turns out positive, I should say. So a negative 3 times a negative x gives us a positive 3 and an x, right? 3 from here, x from here, 3x. And finally, one last time, we'll come from right over here over to our 2, right? And we'll say negative 3 times 2. Well, we only have one negative and one positive, right? Opposite signs, meaning our answer will be negative. And 3 times 2, well, that is just 6, right? So this expression here, when multiplied out, right, to get rid of the parentheses, to simplify for solving for x, for example, in future classes, you want to essentially get rid of these parentheses so you have this entire expression here to work with. Now, one more step that we can do is to consolidate like terms, right? And I'll just go ahead and kind of mark these out, right? So kind of quickly skimming through here, we see we only really have one of these x cubed markers here, right? So I know I can't really combine that with any of these other ones, so maybe I'll just go ahead and write that here. 10x cubed, all right? Can't combine it with anything. But when I come to my next term here, right, negative 2x squared, you'll notice we have this one as a negative 2x squared, and also this negative 15x squared, right? So I know I can combine those, and we say, okay, we look at the coefficients out front, a negative 2, a negative 15, we add those together, right, and if they're both negative, it's minus 15, minus 16, minus 17. So here, we'll have a minus 17x squared, right? We can combine these two terms. I can do the same thing with just this single x here. Go ahead and underline it in a kind of different pattern here, right? We have two terms that have our x in them, right? It's just an x, so we can combine our coefficient. And I say, okay, well, positive 4, positive 3, I'll go ahead and add those together to get a positive 7x, right? And finally, right, we've tackled all these terms. This one's in there. We combined these two. We combined these two. And the one thing that we're missing is this 6 right here. Nothing we can combine them with, right? So we'll go ahead and write minus 6. And this, right, if our goal is to just simply distribute these out, right, simplify this expression, this gives us our final answer here. The important part of this process is keeping track of what has been multiplied by what. And again, this idea of selecting one of these terms, right, one by one, start with the first one, then the second one, and go through and multiply it by each of the terms in the second polynomial, it's kind of universally applicable. For example, right, if I had a nasty problem that looked something like 3, oh, this is the bad marker. Switch over to our citrus green, for example. If I gave you a problem like 2x cubed minus 4x squared plus 2x minus 1 multiplied by 3x squared minus x plus 5, right? This is a lot longer than this problem. I mean, this guy's got 4 terms in it, and this guy's got 3. But this exact same method applies, right? All we want to do is, all right, we'll start in our first one, right? Maybe we just kind of show our terms here to help visually identify them. And all we'll do is the same thing. We'll start here at this first one, right? And we'll say, well, our first term here times our first term here. And we'll go first term times second term, first term times third term, right? That's taking care of this first one, right? We'll check mark there. Maybe a smiley face also, right? And then we move on to our second term, right? We'll take this second term and we'll say, okay, first term here, second term here, and third term here, right? It's taking each of these terms and multiplying them by each of these terms, right? I'll switch colors here so it's a little easier to see. We'll take this third term, right? And say, all right, this one times this one times this one, and this one times this one, right? And finally, maybe put some check marks here. Finally, this guy up here, right, our fourth term, -1, will multiply here by this one and by this one, right? So no matter how many terms your polynomial has, all we really need to do is go through and distribute each of these first ones by each of these terms by each of these terms. And again, so you don't lose track of where you are, what you've already multiplied, I highly recommend taking this approach of selecting each of these terms one by one and multiplying them by all your terms in the second one. Now, to make this a little easier, if you want to do something else, you also remember that by our additive property, I believe, one of the math properties, we can switch the order that these are presented in, right? So if I don't want to do this 4 times, I could also say 3x squared minus x plus 5. And then this first one here, right, is my second one. X cubed minus 4x squared plus 2x minus 1. Right? It's the same expression. It's just here, I only have to do this 1, 2, 3 times. Now, conversely, here I have to do that with each of these 4 now. So overall the same amount of work, but of course it's all about presentation. If you feel more comfortable with this, you can kind of swap these two where they're being multiplied. But the takeaway here is this: select the first one, multiply by each in the second, select the second one, multiply each in the second, and so on and so forth. It's a great way to keep track of your terms and get your answer without having to worry about overlap or multiplying multiple terms twice over by accident. Thank you for watching, and I'll see you next time.